Hello and welcome back. In this video, we will start to learn about the product and quotient rules of differentiation, taking derivatives. So first of all, let's review a few things. So the power rule is when we take the derivative of x to some power, and what we do is we bring down that power and then raise it to the one fewer power. So we'll bring down the n and then raise it to the n minus 1 instead. When we have constant multiples of a function, we can pull out that constant. So the derivative of c times f of x is the same thing as c times the derivative of f of x. The sum or difference of functions, when we want to take the derivative of this, we just take the derivative of each one individually and add or subtract as appropriate. So we can just take the derivative of f plus or minus the derivative of g. So all this is really doing is reviewing a few things that we've seen, and with regard to this last one, if we are adding functions together, we can easily take their derivative. What happens when we multiply? And the answer is when we multiply, it's a little bit more complicated, but there's still a nice rule that we can use. So what we do is we do the following. So we have the derivative of f times g. We are going to take f times the derivative of g, and then we're going to add g times the derivative of f. So when we look at this formula, how can we sort of learn this and memorize this? Well, if we want to take the derivative of f times g, we're going to end up taking the derivative of f and the derivative of g, and we're going to multiply by the other one not having taken the derivative. So again, we have f times the derivative of g, g times the derivative of f. We take the derivative of g once, we take the derivative of f once, and we just multiply it by the other function. Let's see this in action with a fairly straightforward example. So let's find the derivative of this function, which is going to be x plus 1 times x squared minus 2. And what we'll see is that, this is kind of like its own little function on the inside, and this guy is like its own little function, and we are multiplying them together. So f of x is kind of like two functions being multiplied together, this little guy and this little guy. So what I'll do is I will take the product rule and I'll apply it to here by taking the derivative of both of these guys and then combining everything at the end. So if I want to take the derivative of this guy, I'm going to write down a bunch of steps that in the future I'll sort of do a little bit quicker. So if I want to take the derivative of this whole thing, so if I want to take the derivative of fx, this is going to be the derivative of x plus 1 times x squared minus 2, and we want to take the derivative of this whole thing, so I'm going to add some big old parentheses in there. This guy, this is two things being multiplied together, so I'm going to use my formula. Well, I'm just going to write the first one down, and I'm going to take it times the derivative of the second guy. Notice how I haven't taken any actual derivatives yet, I'm just applying my formula. And then what I'll do is I'll add the second guy times the derivative of the first. So I have the first function times the derivative of the second, plus the second times the derivative of the first. Now we can start to simplify. I'm going to write this over here. So I have x plus 1 times the derivative of this guy. And again, I can distribute the derivative. So the derivative of x squared is going to be 2x. And the derivative of minus 2, well, that's just a constant, so its derivative is 0. Okay, so the derivative of x squared minus 2 is 2x, the derivative of x squared, minus the derivative of 2, which happens to be 0. So we can see all that shaping up. And then we're going to add, again, the second part of our function times the derivative of the first part. So what's the derivative of x plus 1? Well, the derivative of x is just 1, and the derivative of 1 is 0. And again, we have the x squared minus 2, that matches up. And then we have the derivative of x plus 1, and that matches up right there. The last thing to do is we can simplify. If we were to leave it in this form, it's kind of clear that we have used the product rule, but quite often they'll ask us to simplify. So first of all, minus 0 and plus 0, well, that doesn't do anything. Well, then I have the second one. I've got x squared minus 2 times 1. Well, that's just going to be x squared minus 2. That doesn't do anything. This first guy, after I cancel out the 0, I've got x plus 1 times 2x, so I'll distribute. X times 2x, that's 2 times x squared. 2x times 1, that's just 2x. And when I consolidate everything, I'll have 2x squared plus the 2x, so that's 3x squared, plus the 2x minus 2. And that is as simple as we can make it. So that's how the product rule works. It is fairly straightforward as long as we've got our formula down. Let's do another one. Here I've got the derivative of 6x to the fourth times the square root of x minus 1 over 2x squared. So here I want to find the derivative. Let's see here. Let's add some parentheses just so we know. We're going to find the derivative of this entire thing. So again, it looks like I've got one function out front, and I've got one function in the back. So what I'll do is I'll use my power rule. So this derivative is going to be my first function times the derivative of the second. So this is going to be the square root of x minus 1 over 2x squared. And I'm going to add the second function times the derivative of the first. So far, I've only used my product rule. It's first function times the derivative of the second, plus the second function times the derivative of the first. Everything sort of matches up with what we had up above. So let's start simplifying this. So 6 times x to the fourth, and then I've got the derivative of everything in here. Well, off to the side, let's remember that the square root of x is going to be x to the 1/2 power. So if I take the derivative of this, this is going to be 1/2 times x to the negative 1/2 power. So far, so good. And then 1 over 2x squared, so 1 over 2x squared. This is the same thing as just 1/2 times x to the negative 2nd power. So when I take the derivative, I'll pull the negative 2 down. So this is going to be minus negative 2 over 2. And I'll take the x and I'll raise it to the minus 1/3 power. So again, this 1/2 stays there. Taking the derivative doesn't delete that. I'll bring down my extra power of negative 2, and I'll raise it to the 1 fewer power. So 1 less than negative 2 is negative 3. Plus, and then we have our second function times the derivative of this guy. Well, again, if I'm taking the derivative of 6x to the fourth, that 6 just hangs around. I can pull that out. And then the derivative of x to the fourth is going to be 4x to the third. Bring down the 4, raise it to the 1 fewer power. So far, everything is making sense. Let's simplify this just a little bit. This is going to be 6x to the fourth. I still have my 1/2. Instead of writing it as x to the negative 1/2, I'm going to put it on the bottom of my fraction as a 1 over a square root. minus a negative 2 over 2. Negative 2 over 2 is 1. Minus, sorry, negative 1. So minus a minus, that's just going to be plus. And then x to the negative third is just 1 over x cubed. Plus, this hasn't changed. And then 6 times 4, well, that'll be 24 x to the third power. So from here, we could go through and simplify this. I don't think it'll necessarily help with anything, but we could make this simpler if we wanted to. The very last thing that I want to show is the fact that the product rule is very helpful, but it isn't always the best way to go about something. So here, we see that we've got two functions. So let's find the derivative using the power rule. And here what you'll notice is that my variable is t, so I'm taking the derivative with respect to t. It's the variable that's changing. So the derivative of this guy, of t plus 1 times the derivative of, times the square root of t minus 1. Well, this is going to be the first function times the derivative of the second. And then we're going to add the second function times the derivative of the first. Okay, so far so good. We've got first function times the derivative of the second. Second function times the derivative of the first. And everything is matching up thus far. If I start simplifying, the derivative of t to the 1/2 is going to be 1 over 2 root t. And we're going to subtract 1. We're going to add that to the square root of t minus 1 times the derivative of, I've already made a mistake here. The derivative of the square root of t is this, but the derivative of negative 1 is going to be 0. The derivative of 1 will be 0, so I need to write that in. So the derivative of t is going to be 1 over 2 root t, and the derivative of 1 is going to be 0. Okay, and then if we simplify this guy, well, I don't need to add or subtract 0 from anything. And if I distribute this guy, square root of t times this guy, the square root of t will cancel out, and I'm left with 1/2. So that's these two being multiplied together. Square roots of t cancel out, and I'm just left with 1/2. Plus 1 times that. And then the 0 I don't need to consider. And we're going to add, again, the square root of t times 1 over 2 root t. Well, square root of t and square root of t will cancel out. So it's going to be 1/2. And then a minus 1 times that. So negative there. And from here, this is just some algebra. What we'll see is that I've got plus 1/2 plus 1 over 2 root t minus 1 over 2 root t. And 1/2 plus 1/2 is equal to 1. So all this work to find the answer was 1. And I claim I could do this a lot faster. Up here, I have two functions that I'm multiplying together. What happens if I were to actually multiply this out? What happens if I actually FOIL that out? So let's do this whole thing starting from the top. This is the function that I want to take the derivative of. Let's FOIL this out. So square root of t times the square root of t is t. Square root of t times negative 1. 1 times the square root of t. 1 times negative 1. These guys cancel. And we're left with t minus 1. Well, and this is really easy to take the derivative of. The derivative of t minus 1 is just going to be 1 minus 0, which is 1. And when we look at this, which way was faster? Well, it was faster to actually multiply these out and take the derivative. So, depending on the situation, maybe it's faster to use the product rule. Maybe it's faster to multiply things out.